Hello and welcome to the distribution team demo. I am Robert, and today we are going to be looking at the rundown of the challenges as I am trying to solve the problem of virtualization on the Mac M1. And when I say virtualization, I kind of mean virtualization scale, which is to say to replicate the way that I do my workflow. So the basic challenges are a couple. For one, for those to use Vagrant. Vagrant currently does not have support on the M1 for VirtualBox, the open source solution that most Mac users have used in the past. VirtualBox currently has a beta out, but the combination of it and then a mysterious issue in macOS is causing problems. And we'll get into what that specific issue is here in a little bit. But let's just start with a screen share. Go ahead and share my screen. Let's see here. Let's take that. There we go. Desktop 2. And share. Okay. So we are in my test environment. And one of the things to know about the M1 is most of us use Homebrew. If you've ever used Linux, you know that there are a couple of things that we use in Linux that are helpful and useful. Move the gallery window here so I can actually see my list out. Now you'll notice that libvrt can now be installed on macOS, as well as qemu. qemu. Now, the qemu is a prerequisite for Podman, so we don't use the Docker desktop. So you can use Rancher. I use Podman. And it has an interesting thing here, just as a proof of concept. So Podman, the way it works is it creates a virtual machine in Apple's hypervisor framework. Now, what Apple has done with recent versions of macOS is created an actual framework for hypervisors. So Podman leverages that. And for those who don't know, Docker Desktop did the same thing. It would create in the background, would create a Beehive virtual machine and load containers into it. Podman does something similar, but using the new hypervisor framework. So when you're using containers on a Mac, you're technically creating a virtual machine spawning containers inside of it. So with this and the fact that this is downloadable either through Brew or you can download it direct. But this basically demonstrates that, yes, we can run qemu machines. So we know the technology works. But there are some interesting side effects. For one, you have to change your virtualization engine. Now, Homebrew does allow you to have qemu, but the defaults still kind of fall into x86. Now, you can get away with that because if you have installed the Rosetta underlying framework, it will kind of fake you out. You'll think it's working, but you're actually running x86 code on top of the ARM framework. And what we want to get to is actually using ARM64 or AR64 architecture default virtual machines. Now, there are a couple of things about running AR64 virtual machines. One, because of the nature of how macOS has implemented EFI, which is extensively accessible firmware interface, which is the firmware that is underneath, like the pre-boot, right? You get power on, you get the firmware or the BIOS, and then that BIOS will hand over to the kernel, which then hands you to user space. For AR64 on Mac, you must use EFI. If you've ever used qemu, libvrt, and all that, you've probably seen cBIOS or some version of BIOS pop up. The default is BIOS. When you use EFI, you have a couple other concerns. So, and this is a lot of setup because you're going to hit things that don't make sense because they're not going to boot. And the reason for that is because of this change. So let's take a look first at the technology behind this. For those who haven't used it before, there's this handy thing called Virsh. Virsh is a virtual machine interface. If you've used qemu and Virsh before, it's basically the same thing. But it allows you to define your virtual machine as what they call a domain in XML. So if we look at say my Alma Linux. So if you look at that long bit right there, that's just an ISO that I downloaded with Packer. Okay. And this is what defines a domain. And the thing to notice here is your EFI firmware. Now, when I test, I want to use default setups, so I don't want to install every time. So what you see here, this works, and this is kind of my first iteration, was can I get it to boot up, and can I get it to allow me to install? And this kind of works. But I want to get Packer to install as well, because we do have defaults. So let's come up here. Okay. So with Packer, one of the things to know and this is a personal library that I have that I've created for myself for other things. I adapted it for here, is that you have to change things. So in Packer, that EFI thing we talked about, Homebrew puts this code into a, you have to override this, because the default for this is user local, qemu, and then a BIOS. So we have to override it. You also have to set the default vars file. For reference, what is a vars file? In extensible firmware interface, when you load, like when your computer boots up with EFI, unlike BIOS, which loads all your options and your configuration into a small subfile that's loaded on the disk, EFI is like a separate partition where your variables are stored. Fun fact, on some systems, if you get too many EFI variables, your machine will refuse to boot and will fail. So if you ever are booting an EFI machine and it just outright fails, you have no idea why, go in directly into your firmware and delete some of your options. I think 100 is the max you can have. So you set your vars file directly. This lets you get into the Homebrew one. And the boot command, we'll show you this here in a second, but the boot command is how it automatically sets up. But the real magic here is in the qemu args, because qemu, there's some problems. For one, you have to set up your pflash. This is part of how it knows how to store the variables as you set up the machine. Now you see this dunk vars. This is it takes the default vars, copies it in, and then creates a new one based on the settings you're creating. I have to turn this to a variable, but again, that's my ISO download. For the installer, again with Packer, we're going to create an image. But all of this, setting up the ports, the devices, all of this is because qemu right now doesn't easily detect a lot of the devices in the HBF setup. And that is something that you'll see up here. We commented it out, but your accelerator on a Mac has to be HBF. And we set that up down here in the options. One of the big challenges we face is that depending on where you set certain options, it may set twice. So you have to pick and choose, like here. The machine type is vrt 8.0, and that gives us the correct machine type emulation to get these devices. Again, there's a lot of weird things here, and this is because qemu and Homebrew, a lot of the defaults just assume x86 and x86 hardware. So for right now, we're basically climbing the hill, going both ways, because it works, but you have to override everything to get into this AR64 mindset, which is to say that you go from BIOS to EFI, you have a framework, you have the way the device tree is presented is different. So you're dealing with a lot of problems. This QAM memory, believe it or not, is a mandatory field for Packer. You have to set that up. Now, I've not had to set this for just running the machine, but for Packer, for whatever reason, it freaks out if I don't set this, right? And give it this mock virtual RAM memory system. So, and all this was just trial and error. This was 3 hours of Jason Plum and I just between our knowledge of firmware, bootloaders, and other, just adding options and figuring it out until it worked. So let me see if I can demo that. Let's see here. Yes. I'm asking to build us a set. For those who haven't seen Packer, and we'll get this up real quick. What is that? It's on 5994. So this is where it gets to, and this is where you see that boot param. It's editing and setting this up. This is different from x86. So this is just another side note that when you're installing on AArch, this boot screen changes a bit. So this was the product of quite a bit of work. Now, as to the other pieces, so we'll let that. I failed to engage tmux. That's my fault. Come on. Here we go. All right. Let's see. Other things of note. Yes. So now one of the things that is not working in Vagrant is that when you start up the machine, with you Vagrant up, it'll finish. But if you check the error code at the end, it's the error code 256. And this comes back to when we talk about what are the challenges. So one of the things that I do is I stand up multiple virtual machines at a time. So I want orchestration method for standing up, say, 3 Redis instances, or standing up 3 database instances, or stand up like just a partial of an HA environment so I can do testing. That doesn't work right now because I can't orchestrate it. And there is a reason for that. So all this magic under the hood is this. And this. On Mac OS, you can check typing check for the morning, I guess. All right. You can check attributes. Now this right here, this is the current blocker that I've hit. Now this is a tag that Apple puts on machines, on various files in your machine. What this means is that this device is not allowed to make certain changes unless it's code signed. The only way to get around this is turn code signing off, which is a thing that we don't do by security policy. Now, why is this important? Well, that's important because one of the core technologies behind the virtual machine, and this goes back to so I have this bridge set up on my machine, right? Because virtual machines, there's a couple of things you need to do. You can have the virtual machine, it can connect to the internet, but also you can have it talk to other machines only. It's called an isolated virtual network, or you can bridge it. And bridging it does this thing that allows the host and other machines to talk to each other with names. On my setup, will this be a public to the world video, or is this just public to us? Okay.
Public to the world by default.
Okay. I don't really want to expose my internal lab configuration, but all my machines have DNS set up so that when they come up, I can route packets between all the machines. With that said, I can't get this to work because I'm trying to use a tap driver, the tap network driver, to connect to basically tap in an interface on the bridge. That doesn't work because macOS says unless you're a signed code package, you cannot do that. And that was the latest thing that I hit. I hit that last night, knocking my head on the wall for a while. But that is kind of the be all end all. So current state, I can stand up a virtual machine and it can run, but it cannot create a network on the bridge. It can only create a NATed with pass-through, NATed with pass-through machine. So if I want to run, say, 3 instances, I'd have to give each a different forwarded port on my machine. That's the current state of things. Now, there are 2 ways around this. One is somebody from here signs up for a Apple developer license, and we sign the package and we actually create this. I don't know if that's tenable. I certainly don't want to maintain that much stuff. I'm going to talk to some friends at qemu upstream and libvrt upstream and see if there's any appetite for that, because we have a Apple developer license for signing the Fedora Media Writer package. If any of you have installed Fedora, you know that you can download the Fedora Media Writer and write that package on macOS, and it's a signed application. If you open it up, it used to say, I think it used to say my name and Mohan's name, but I think now it's just Mohan's name. But you know, that's how you get things to work on macOS, is you sign the package. The other way to do it, and I have to look into this, support recommends this piece of software. Go. UTM. Now, UTM is open source, but they have to go through Apple for the code signing thing. But this creates virtual machines. Now, the problem with UTM is that while it does do this, and it does claim to be QEMU without the headache, what it doesn't do is it doesn't give you a programmatic interface. Like, I just want to set up and automate installs. Now, they've been adding some, but this is kind of the next thing to work on. They provide an AppleScript interface. Not a Ruby interface, not a programmer's interface, but an AppleScript interface. And so there's a lot of discussion, and just to kind of bring in some of the research, right? So here's the discussion upstream about the VM network. And again, this is because you need an elevated permission, which the code signing won't allow. But you run into this because of the lack of code signing. So the upstream project is discussing the code signing and the entitlements. And that comes from, if you haven't seen it, system integrity protection, which is why we can't do anything with the tap networking. So the other thing that we can do with this would be to use something called Ruby OSAS or ASAS and create a Vagrant driver for UTM, which I think is the next thing I'm going to try and work on in my spare time. Because the only way to get back to this workflow locally is going to be to get UTM, which has the code signing, set up to accept Vagrant inputs. And it didn't accept that 6 months ago, 4 months ago. They just recently, and I'm looking for the, here it is. So Vagrant libvirt, somebody wrote a thing, it doesn't quite work so well, but there's been a lot of discussion around how to make this work, both in upstream libvirt, upstream Vagrant. And right now, I think the general idea is, because of the code signing, is to try and add a Vagrant plugin for UTM. And so that's kind of the state of the world, right? It works. You have to do a lot of twiddling to tell it which firmware to use, because EFI, not BIOS. You have to kind of add a lot of different device drivers because it's not auto-detecting them yet. There is some work going on upstream, but a lot of the support came in with QEMU 7. We're at 7.0.8 right now. So we're getting patches as things come in. Some of the challenges. The core functionality of how, let me turn off my screen share right now, of how all of this works is that you use a TUN-tap networking driver to create a tap interface, to add it to your bridge, to allow connections, to allow DNS. All of that is blocked by macOS. So that's kind of the big boulder in our way. UTM code sign, so it gets around that. But UTM uses AppleScript, which really isn't supported by a lot of the open source projects. And so like if you try and use, like I actually downloaded and compiled, not compiled, but I downloaded and modified libvirt Vagrant to run on M1. So libvirt Vagrant is what like Fedora ships to allow libvirt to connect to with Vagrant. You can do Vagrant up, and instead of using VirtualBox or VMware, which is two of the standard backends, this is what allows you to patch in and use qemu libvirt as your backend. Patch that to work on the M1, and a couple other folks have done similar things. And we got it to, you get it to work as long as you do a force install of the AR64 version of Vagrant. When you install Vagrant through Brew, by default it installs the x86 version. Should probably show this. Share my screen. Desktop 2. So for those who don't know about this, in Brew, you can go Brew, Edit. And if you see here, I have changed this to this. This is AMD64. Oh, I did a Brew update today. Okay. So just blew that out. But you can change this to the AR64 and change this checksum, and you can get the different package. And that getting this as AR64 is what will allow it to actually invoke the correct QEMU. The problem is, again, that it fails, and it fails because it tries to do that tap network and it's not code signed. So that's kind of the stopping point for the Vagrant libvirt stuff, right? Somebody's got to pay up for the code signing, and where to put that into the ecosystem and who's going to cover it, who's going to pay for it is kind of the big question. So the next step is going to be to put a wrapper around UTM and their AppleScript and get that into a Vagrant plugin. And I think the way to do that is going to be to take the current work in the libvirt, fork that, and then modify that to use UTM, that open source with code signing that uses QEMU under the hood virtualization system. So that's kind of all I got. That's been 9 days-ish worth of work trying to recover my workflow on M1. And right now it looks like it's really, I think at this point, my personal thought is I'm going to try and automate standing up a machine in GCP for right now, because even though I have a whiz-bang 64 gigs of memory machine, it's basically unusable for the workflow because of between code signing and firmware challenges and stuff not running, hypervisor issues, plugins not working. There's a lot of work to be done to make it work. So the other option I think would be to, if we wanted to, purchasing a license for VMware would immediately skip you by all this, and Vagrant would just work because that's already done. That's a purchased software version. So there's no open source, and I don't know how that licensing works. But yeah, that's kind of the sum total of the last 9 days of my life, and that's where the state of M1. So at the end of the day, a single virtual machine, yes. You can't access it from the outside world. It's not routable, but it does connect to the internet. It's through NAT only. It does install. You can install GitLab. For those who saw my post around it, what does GitLab look in the text browser? I basically accessed the standing up GitLab through a Lynx text browser on the shell. And that let me talk to the instance that stood up to make sure it was there and I could log in. Which is laughably funny trying to use GitLab in an all-text web browser. But don't laugh if it works, right? I just had to prove that it was there and I could log in to set up. So, yeah. Other questions? Comments?
Yeah, so at the beginning, you were indicating that Podman was working. I'm curious, and then you were showing, in Packer, you had to add all these extra flags to qemu. For Podman, is it just like that they've already figured out, like you mentioned in Packer, the auto detection is off or not working correctly, right? So is it more that like Podman's auto detection was working and setting those up correctly?
Yeah, more that they just configure. Yeah, they configured it all. Like they explicitly support Mac OS with Podman desktop.
Okay.
So they've done all that work kind of under the hood. So yeah, there's a lot of FUD. Like I think I could probably cut some of those options out that we figured out. Like as I look at it more, it's just what I'm weighing up is, my time in digging into this and making it work versus I actually have to get work done. Like right now, I'm in this state where I literally cannot do about half of the reviews I typically would take because all of my tooling, all of my setup is all a local virtual machine setup. And I can't even initialize a virtual machine right now to like do that testing on an automated scale. Like, I don't have x86 to show this, but let me see if I can show this. Like when I test, so this is an old project that I did a long time ago, but all of these different directories are different methodologies of setup where there's a vagrant file.
You're not sharing your screen at the moment.
Oh, did I not hit share? Sorry. All of these are example configurations. So like medium is like 1 plus 2, like front node plus database plus a Redis, right? Minimal console is just 3 console nodes. External Nginx, external Redis, these set up like an external load balancers and such. Container registry does exactly what it sounds like. Tiny is for like Pi style testing. SE Linux Dice Stig is for like testing SE Linux under very constrained purposes. Apache Proxy is front end, running a Docker install and running GitLab and Docker. Also GitLab and Docker with like a proxy front end because we've had community members ask about that. So I have a testing framework to test a lot of things that have just come up. And I have a GitLab RB that auto-injects SSL and templating. I have all of my local lab sets up all the DNS, so everything just works. I can do full sign certificates, the whole 9 yards. All of this is unavailable to me because M1 basically completely blocked it. And that's why I'm trying to get there, because this is pretty much an integral part of my workflow to be effective at doing what I do. So that said, I forget what your original question was, TJ. Oh, you already answered about Podman. Sorry. been that kind of day. I was taking more coffee. So, yeah. But at this point, I think I've been trying to work through an alternate with our sandbox. There's a way you can apply Terraform templates, but the template is deeply complicated. I spent about 4 hours last night just trying to figure out what it needed for me to stand up an instance, and I couldn't make head or tails of it. So I gave up, and I'm going to try looking at that again today. Because this ability to stand up a machine, especially for a good example of this, one of my primary things that I do, everything I test, every time, I always install on Enterprise Linux 8 or Enterprise Linux 9, or now Enterprise Linux 9. And the reason I always test on that is that we don't have any coverage for any of the SE Linux distros. So whenever I get an MR, I always run all the testing through Enterprise Linux package, because then I see, does SE Linux work? I kind of poke around extra, like, hey, did I get any weird SE Linux errors? Did anything pop out at me? Anything out there? That's kind of something I just do because it provides coverage to that side until we get the approval to automate it and pay for the pipelines for it. So that's kind of a workflow that's missing now, right? Like, so I'm going to convert over to trying to use GCP and get that set up. Take the jobs that I have there, they're configured right now, they're just shell scripts. I'm going to convert them into basically Ansible template jobs, which is, you know, fairly straightforward to do, but like transform them over and put them into GCP, but that's probably going to take a couple of days. I did try and do a basic Terraform because the pre-provided template is way too complicated. I mean, it's like, it's this whole laundry list of variables to set, but you don't know what the defaults are. They're not clear. So I just tried doing a basic one, and I got permission denied, even though I set up my key to allow me to do provisioning. So that's going to be some time. I'm probably going to reach out to the Sandbox channel and be like, is there a more straightforward, I want to set like kind of like we do, set the domain name and set the distribution, the Linux distribution, and move forward. Because there's nothing that straightforward available right now. But yeah, so like right now, as far as I can tell, the only way to effectively use M1 for like actual deep testing is to pay for a VMware license, because the tooling around UTM is just not there, because they've elected to keep it very close to the Apple ecosystem, which is good for all the Apple users, but it's terrible if you actually want to orchestrate a large number of containers, right? Like this, you know, the laptop that I have, I explicitly got with the 64 gigabytes of memory and the extra space so that I could virtualize up to 10 or 12 or 15 machines at a time. Because that is actually a thing that I have done, albeit my laptop tried to set itself on fire. But on my previous Intel laptop, I would set up 10 virtual machines and they'd run. As macOS got more and more bloated, it became more and more difficult because the base OS takes too much memory. So with this newer M1, I was hoping to leverage the efficiencies. Unfortunately, between the lack of support, we just got the qemu support, I want to say about 8 months ago. You could get it if you compile it yourself earlier, but it didn't release to the wild until version 7. Code signing, lack of Vagrant support, which if you do install Vagrant, make sure you swap over to the AR64, because by default it uses x86, which will look for x86 items and will break your virtual machines. But yeah, there's just a whole pile of challenges, and it's actually kind of surprising to me that M1's been out for almost 2 years now, and the community hasn't solved a lot of these. So there's still a lot of kind of new architecture growing pains. And I think a lot of it comes down to Apple's code signing, right? Like AR64 has plenty of support for all this stuff, but Apple's code signing puts roadblocks into almost every step of the way. So sounds like there's a cat here, so I apologize for that background noise. So my kitten's mom is still a stray outside. She won't stay, so we trying to get her in. That said, that's the main challenges for M1 right now, is that we just Apple's code signing has blocked a lot, and then also the open source community doesn't typically use Apple, so a lot of that support, like, it took a lot of time. Bonus sides though, Podman fully supported. It does work. For those who use Podman, it's just, you know, Podman machine to manipulate machine, but then once you're in, you can do your typical like Podman image ls. Just any Docker command you can think of, just replace it with Podman instead of Docker, and it'll work. So that does work. So if you have a container workflow, that does sort of work. Caveat emptor, I've got to sit with Jason for a bit, because there are some things that when you run the container, for whatever reason, you get a binary mismatch. It's supposed to run through Rosetta. It doesn't necessarily. So that's another thing that like build's gonna have to look at, is getting all of it. We're looking at that now, getting all the containers compatible with AR64. Because currently all of our stuff runs on x86. So yeah, just lots and lots of growing pains. Lots and lots and lots of growing pains. Any other questions?
No, I think that's it. Thanks, Robert. Thanks for showing off your setup there and giving us some hints and places to look for those of us who might want to try this or are thinking of ending up with a new Mac in our workflow as well.
Yeah. For right now, my recommendation, if anybody just wants, if anybody wants my 2 cents, my personal recommendation right now is if you are looking to be productive and effective, I strongly recommend against the M1. Like the whole platform and the way Mac OS has set it up, it's kind of antithetical to getting a development environment working and efficient. If you want to do just a single stand-up machine, that works fine. If you're insistent on getting an M1, plan to work in GCP and don't bother with the extra memory. Like, don't waste the company money on it. That is kind of a thing that, like, deep down, I'm kind of deeply frustrated by. If I had known it was going to be this many other things, and that I got this machine in July, and I've been kind of playing with it, waiting for the community to catch up, kind of tinkering with it for almost a year now. And yeah, it's just not ready. So if you're going to get an M1, get the least smallest thing you can get away with, and plan to do all your work in the cloud. Which, unfortunately, for folks like when it rains, here in Florida, internet gets flaky. I know Balu has some of the same problems in local to India. The internet can get flaky. So if you have very flaky internet, the M1 is a very bad choice because a lot of your stuff is going to be cloud-based. If you don't have a lot of that kind of work, like the containers almost just they kind of work, but you're going to have a lot of problems with the AR from the translation. Like Rosetta's there, but it doesn't catch everything from the standpoint of the container. And part of that is because the command line interface and Rosetta don't work well together. Like Rosetta does really well. Any GUI application that I've tried to go with, Rosetta picks it up, it does fine. But when you get into the command line, deep into the command line, underlying things, because a lot of these are done to either configs or they're direct catches, like some of the stuff for QEMU, you can configure it, but some of it under the hood, it does detection and looks for like, what was it? QEMU libvrt tap is a assistant helper that doesn't ship with the ARch version, and it's hard coded in, you can't get rid of it. So it's a bridge helper basically to create network bridges. The other one, if you've used Vagrant in the past on macOS, newer versions of macOS no longer allow promiscuous networking on the Wi-Fi. So if you're used to setting up bridges on Wi-Fi in macOS, which doesn't work in your Linux, you have to have a wired connection. macOS now follows what Linux does. So you won't be able to kind of cheat your way through and get a bridge of multiple machines using a promiscuous network mode on a Wi-Fi interface. Mac got rid of that apparently, not in the current version, but the version prior, which I just upgraded to all that getting this new machine. So that's another challenge if you've used this in the past on Intel Macs, is you can't use your Wi-Fi for mass bridging anymore. You used to could for like years. So, because before my work Mac here, I had an Intel Mac that I did the same kind of workflow on, and you could do that on the wireless. Whereas on Linux, you have to have a network, a wired hardware interface to do that bridging. So there's a lot of little gotchas. I think that's why I recommend against it. If you have a virtual machine style workflow, the M1 is just not mature unless you really, really want to dig deep, like go really deep. And just for background, I used to be a maintainer for the Grub2 project. So I have multiple years experience in bootloaders, firmware interfaces, and I'm finding it to be a struggle. So just caveat, buyer beware. The M1 is not ready for a virtual machine workflow. Unless you want to spend another, I think it's $200 on a license for VMware. This VMware works with Vagrant out of the box, apparently. Supposedly. I don't know that I want to ask to spend that money, but that's where to find out that it doesn't, then the money's already spent, right? But yeah, that's kind of where it's at. So, so yeah, 3 of 10 would not recommend the M1. So, yeah, that's the state of things. So maybe I'll do this again in another year. We'll see where we're at. But for right now, it's kind of still a massive pile of pain. So
Yeah. Thanks, Robert, for showing off the demo today. And yeah, I think we can sign off here.
all right. Well, thanks everybody. I hope you all benefit from the diving. And like I said, if anybody's interested in this stuff, I might start doing like maybe an hour of just struggle sessions where I just broadcast it. Whoever wants to come, we can kind of work our way through it together, because I know there are a couple of us with M1s on the team now that have varying levels of success at, the big one I think is going to be getting the cloud native and container stuff working with it, because for that it's much easier to test local. So I think I might start broadcasting that. So for folks who see this video, if you see me advertising for that, you are more than welcome to come and just bring a pot of coffee, because it's gonna it gets pretty deep pretty fast. So yeah, but thanks everybody, and have a great, it's Thursday. Have a great rest of the week, and we'll see you on the internet. Bye.